Let's do problem number 3 on adding vectors, part 2. And number 3, here's what's given. Vector A is 21.8 meters. In the x direction and the y direction, it's negative 15.2 meters. Vector B is negative 38.9 meters and 7.3 meters in the y direction. First thing I like to do is just draw a little sketch of the problem. And I say, okay, it's going to go to the right, and then it's going to go down, and then it's going to go to the left, and then it's going to go up a little bit. So I don't know. I'll just fit it in here somewhere, my sketch. And I just draw my x and y. So A is going to go over 21 and down 15. Now look, I don't. Somebody asked about the sketch, and this is the part that students do have the most problems with, is drawing the sketch. You just want an approximation. I don't want you to spend 10 minutes on the sketch. I want the sketch to take maybe 30 seconds. So I'm going to start at the origin here, and I'm going to say, okay, A is 21.8. Well, let's make that 21.8. Well, if that's 20, how do I know that's 21.8? Because I say so, all right? And then it goes down 15. Well, what is 15? Well, if this is 20, 15 would be about like right here, but I'm going down. So it's just kind of an approximation. There we go. So here's 21.8, and there's that. So there's vector A, a sketch of A. And then B is going to be, now, here's what I'm going to do. Look, starting where A ended, I'm going to go in the x direction, I'm going to go negative 38, which is almost twice, be like over here somewhere, and it's going to go up 7.3, which isn't very much. So vector B is going to look like this. See what I did? I hooked up B to the end of A. So A starts here, goes over like that, goes over 21.8, down 15.2, just roughly, okay? And this goes, whoa, that's way bigger than this, so it's going to go way farther over, and then it's going to go up a little bit. But you do that from where A ended. When you add vectors, you're hooking them up head to tail. Okay, so R should be somewhere over here. Now, what does this tell me? Well, R isn't going to be very big. It looks like R is going to be smaller than the magnitude of A and B. And it's going to be in the third quadrant. And it's going to be 180, I don't know, plus 30. So it's going to be around 210, plus or minus 10 degrees, somewhere around there. Now, let's actually do the work and see, if my estimate, my drawing, is actually true. Here's A equals B equals, so we're going to add them like this. Now A is 21.8 meters, negative 15.2 meters, negative 38.9 meters, 7.3 meters. Now, do you see that these are already in rectangular coordinates? These are already in x and y. So I can add them right now. They're not in polar coordinates. I don't need to convert them to rectangular coordinates. Okay? So in the later problems, 5 through 9, I give you the vectors in polar coordinates. So you have to do an extra step. You have to convert it to rectangular coordinates before you can add. If you add vectors in polar coordinates, you get something that makes absolutely no sense at all. All right, so now we can add this. Let's see, 21.8 plus negative 38.9, and we get negative 17.1. That makes sense. And then negative 15.2 plus 7.3. We get negative 7.9 meters. Now, doesn't that make sense? Look, this is negative. That means I'm in the third quadrant. Woo! All right. Now now this is r. And this is r in rectangular coordinates. But I want the answer in polar coordinates. So the magnitude of r is going to be the square root of 17.1 meters squared plus 7.9 meters. And notice that I dropped the negative when I plug it into Pythagorean theorem, because the negative is going to get canceled out anyway. Please do that, because some of you are going to make the mistake in your calculator where it will actually you'll accidentally subtract these instead of adding them. So that can be a bummer. All right, so there's my calculator. Let's see. So we're going to take the square root of 17.1 squared plus 7.9 squared, close parentheses. And notice in my calculator, look at that, the square root sign there. Notice that I put everything in parentheses like that. So it just makes sure that the calculator gets me the answer I want, which is the correct answer, actually. R equals 18.8 meters. Now, tangent, the angle is going to be the inverse tangent of the y value, negative 7.9 meters, divided by the x, negative 17.1 meters. Now, do I have to add 180 degrees to this inverse tangent? Yes, because the x component is negative. Okay, so that means that theta, let's see, tangent inverse. So that's going to be negative 7.9 divided by negative, well, that was silly for me to type in those negatives, but I did it. Enter. 24.79. Now 24.79, that's in the first quadrant, but we're 180 degrees away from the first quadrant. So I'm going to add 180. And I get 204.8 degrees. Well, let's just write out vector r now. So we'll say vector r in polar coordinates is equal to 18.8 meters at an angle of 204 or 205 degrees. I should probably round it to 205. But so there's my answer. Now, does my answer match my sketch? Well, the angle looks good, and the magnitude 18.4. Yeah, it's kind of, it's not very big. Certainly compared to these guys. So yeah, it looks right. It looks right. So I didn't make some kind of crazy mistake on my calculator. Okay. Any questions? Yes?
When you're drawing a sketch, why don't you start vector B at the origin?
Okay, so the question is, when I draw this sketch, why don't I put vector B at the origin? Because the addition operator, when you go vector A plus B, what is this plus sign telling you to do when you're adding vectors? It's telling you to hook them up head to tail. Now A goes first. A goes first. So you just go, you draw vector A, but then it says now you gotta start vector B where vector A ended. That's what it means to add vectors together. So if you put the tail of vector B and you start it right here, you're not adding vectors. Okay, so you're just not following the correct operation. So by definition of the operational definition of vector addition, you have to hook them up head to tail. Any other questions? That is all.